Let us discuss normalization in this video. Normalization in DBMS. Normalization is a technique which is used to remove the redundancy from the database. Redundancy is nothing but repetition of the same data. When you design a database, after designing, when you look at the database, some places, some data will be, if you look at one data, that will be in some other place also. So not only one place, not only in one table, same data will be repeating, or it will be in some other table also. Like that, some data will be in redundancy. So we have to remove that redundancy. Otherwise, we have to reduce the redundancy for effective storage and utilization of DBMS, because data in real time will be very. So if a large number of data, large amount of data is stored in multiple locations, then it is it is just like this unnecessary storing data in multiple locations. That's why we have to reduce it. And to reduce that one, we cannot simply delete something. We have to examine the database design properly and find out where the redundancy is existing, and we have to properly remove that particular redundancy without loss of the data. Otherwise, without loss of information. That is what normalization. And in this normalization, we use functional dependencies. Okay, for functional dependencies, you can refer some other video in which I have explained the basic concepts in functional dependency. So those functional dependencies are used in normalization in order to identify the redundancy, and we eliminate those redundancies in database by using normalization. And normalization is having so many forms: first normal form, second normal form, third normal form, fourth normal form, fifth normal form, like that. Different forms are there. We have to discuss all those things. Okay, what is first form, what is second form, what is third form, what is BCNF. Okay, up to that BCNF, let us discuss in this video. Okay, now the first one, normalization. In normalization, we look for redundancy. There will be redundancy, and we will try to eliminate that redundancy. Okay, we characterize the level of redundancy and of the database or tables, and we remove the redundancy. Means what? The existing design of a table or a relation or the database will be modified in order to remove the redundancy. Okay, so those mechanisms are provided here in normalization. Of course, this uses functional dependencies. Okay, and here there are around 6 normal forms, but in this video, let us discuss about the first 4 normal forms: first normal, second normal form, third normal form, and BCNF. Okay, up to BCNF, let us discuss. Most of the DBMS follows or uses up to this BCNF. Okay, very rarely 4NF, 5NF, and 6NF. Okay, now the first normal form, they're telling no repeating groups. Sometimes we may store multiple values in a single cell. That's nothing but multi-valued attribute. If it is like that, you better remove. That is what first normal form. In first normal form, there should not be any repeating groups. Okay, and if there are any repeating group, then separate that repeating group in the however you want. You can separate that one. You can form a new relation, new table, and keep the repeating things in that. Otherwise, you can store the same, repeating values in multiple cells. All those things we will see. For suppose, okay, if you are creating a new relation, then the primary key, PK here is nothing but primary key, should have a combination of these two. That nothing but the original relation. There is a relation, there is a table. In this table, there will be columns and there will be rows. In those rows, otherwise one column. In one column, the values are multi-valued. Okay, okay, value 1, value 2, value 3, multiple values are there in one cell. Okay, that is what this no repeating groups. So what we have to do is we have to separate them. Okay, if it is like this, then if it is like this, then it is um, not in the first normal form. If you remove this, then it will be in the first normal. That's what this point. And when you create a new table or new relation, okay, and within that new relation or a table, there will be primary key of the original table. Means what you are creating a new table. For suppose this is the new table with these columns, and in this table, the primary key should be placed. Okay, of the old table. Okay, this is old table, and for suppose this is new table. Okay, and this thing should be placed in a new relation in a different manner. Okay, so that's what an attribute from the newly created relation. Okay, now for suppose let us look into one small example. Okay, there is student grade report. In student grade report, okay, we have a student number. I mean, there's nothing but let us look into this term properly. There should be student details, there should be grade, his marks details, and its report. Marks means which subject. So there will be student details. Student details are like this. For suppose a number of the student, name of the student, and measure of the student, and grade marks. But with which course? So these are the course details. Okay, and for the course, there will be some instructors. So these are the instructor details. So there are student details, there are course details, and there are instructor details, and finally the grade. Okay, so we created a table like this, initial table. Now, what is first normal form? In first normal form, okay, the value in a cell should be atomic in nature. Okay, it cannot hold, atomic in nature is nothing but it cannot hold multiple, values. Okay, so for suppose in this example, if you take one student may take multiple subjects or multiple what is courses. Okay, so at the time single cell maybe we have to place multiple values in a single cell, something like that. So what we have to do, we can separate this single table into two different tables. Okay, earlier it was student grade report, now it becomes student table and student course table, student table and student course table. Okay, now in student table we are storing the details of the student. Okay, in student course table we are storing the details of the course. Of course, simply course we are not storing. Okay, it will be this previous table should be linked with this table by using one column, that is nothing but pk. Pk is nothing but primary key, so student number is pk. Okay, that same pk is used in the new table along with the remaining details. That nothing but there should be a link between that old data and the separated data, the main data and the separated data. Okay, then for suppose let us look into one more example. Okay, in first normal form, each cell of a table should contain exactly one value. Okay, when you look at this column course code, George is an instructor who is teaching two subjects or two courses. For suppose. Okay, now it should not be like this is multi-valued, and it should not be like this in first normal form. So what you are supposed to do is, what we can do over here is one more example is, okay, we instead of writing in a single row, we are writing in multiple rows. George teaches CS 101. George also teaches CS 154. Okay, now the problem over here is in the first in this old table. The problem is, okay, if you want to edit some information related to 101 CS 101, we do not have to touch the data corresponding to one. We have to touch the data. For suppose if you want to delete 101, only 101 you cannot delete over here. You cannot delete over here. Okay, because the CS 154 is also along with that. But when you look at a first normal form table, okay, if you want to delete for suppose CS101, then directly you can delete that CS101 and it will not affect the CS154 like that. Okay, so first normal form atomic values. Okay, if those if atomic values are not there, then it is not following first normal form. So you are supposed to either you create a new relation, otherwise you keep the data in a separate row. In those two fashions, you can bring a table into first normal form. And let us enter into the second normal form. In second normal form, first and foremost thing is it should be in first normal form first, then only okay remaining things. Okay, what is that? In the second normal form, they are telling primary key should comprise a single attribute. Of course, composite also can be placed, but what happens is when you composite in the sense there will be, for suppose 1, 2, 3, 4 columns are there in a table, and first two are primary key. Now these first two primary keys should be should determine the remaining. There's nothing but determining is nothing but functional dependency. Okay, so partial dependency in the sense, for suppose one of the key may have some dependency with some non-key attribute. That is what partial dependency or augmentation. Okay, so you better maintain a single attribute, otherwise both attributes should determine each and every non-key attribute. If one of the attribute is determining the non-key attribute, then it is partial dependency. That should not be there in the second one. So that should be eliminated. Let us go through this example. Earlier we have two tables, student and student course. Okay. Now here when student number and student course both are I mean that is a composite primary key attribute. Okay, so generally what should happen from these both, there should be a dependency between name of the course, number of the instructor, name of the instructor, instructor location, and grade. But when you observe carefully, only the grade has full dependency with the student number and course number. Means what, we can identify a student grade by using both student number and course number. You cannot simply give a grade to student number. We have to tell which course also, which subject also. So student number as well as the course number together should be used to identify the grade. But when you come to course name, only course number is sufficient to identify course name. Okay, similarly course instructor number, similarly instructor location, similarly instructor name, all these can be identified without the help of student number. So it is partial dependency. So we have to eliminate that partial dependency. So what you can do, you can create one more table for suppose course instructor, and take out that partially dependent attribute from the primary key and place in another table as primary key, and all the dependent attributes should be placed over there. What are those dependent attributes? Course name, instructor number, instructor name, instructor location. That is not grade, because now grade is fully dependent on student number plus course number. Okay, grade cannot be identified by using only student number. Grade cannot be identified by using only course number. Both together should be used. For that, that whole table is kept just like this, but the remaining attributes are removed because they has a partial dependency with course number. Brought this table into our database into a second normal form. Okay, of course you can go through one more example also. Okay, what they're telling, take each non-key attribute and check. Non-key attribute means, for suppose course number, instructor name, instructor location, grade, all these are non-key attributes. Okay, and check if it is only dependent on part of the key. Part of the key means key is student number plus course number. Okay, part of the key means either student number or course number, only one, that is part of the key. If it is like that, if there is a dependency, then underline the copied key as the primary key of the new relation. Means what, you form a new relation and place that part of the key as a primary key in that particular table. Okay, so remove the non key domain along with a copy of part of the key if it is dependent upon to a new relation. That's nothing but you take all these non-key attributes and place them in the new table. Okay, so for suppose title and actor both together should be used as PK, means what? Primary key. Okay, both together should identify the director of the movie. But the point here is title can be used to determine the director. Okay, no need of the actor. Okay, so this is not in the second normal form. So we have to bring it to second normal form by dividing this single table into two different tables. Okay, so one is uh, the title has dependency with the director, so that is one table, and actor is having dependency with the director, so sorry, title, so that is another table. So like that, two different tables we created, and we brought that table or database into a normal second normal form. Okay, so third normal form and BCNF, let us discuss in another video.